All right, so the next section, we're moving from our discrete variables, right? The number of oil spills off the coast of Alaska, to our continuous variables, the height of a randomly selected student. So these are the things that can take any value on a range. So when we're dealing with these, we cannot list out the entire list of values like we did with the discrete and just put them in a beautiful table, because there's an infinite number of possibilities. So instead we use a density function or a curve, to, where did I even go? To demonstrate these probabilities. So what I'm talking about here, this probability density function, you almost always, that's not the color I wanted. You almost always have your probability of x, and we're going to see this in a second, and then your x. And then we're talking about this area under the curve when we're finding probabilities, because we're going to have this idea. So in order for us to have a probability density function, all of our probabilities have to be legitimate. And technically this isn't even the probability, this is actually the function itself. The sum of all the probabilities, or the area under the curve, has to be 1. The area under the curve for a particular interval is the actual probability, and probabilities for a single outcome are basically 0. So if everything here is about area under the curve, a single outcome, like saying what's the probability somebody is exactly 5'5", well, technically, if we're talking about a continuous variable, the probability of somebody being 5'5" is 0, because there's no area to a line. Now, we typically talk about height as being something discrete when we actually report it out, so you can see why this is somewhat confusing. But if we're talking about 5'5" to 5'6", now we can actually find an area under that curve. So lines themselves will have no area, and so the nice thing here is all that reading carefully for do we include 3 or not include 3 that we had to do in the binomial, now it doesn't matter. It turns out our probability that x is less than or equal to 3 is the exact same as the probability x is less than 3. So we can read a lot less carefully in the continuous land than we did in binomial land. So let's see what this looks like on some questions. So our first question here says, a random number generator will select any number between 0 and 1, not restricted to integers, so that means that any value on that range, which is our definition of continuous, with equal likelihood. Find the probability that x is, and then we've got some of these things that we want to find. So we know it can be anywhere from 0 to 1, and it's all equally likely. So our probability density function is just a straight line. This is what we call the uniform distribution, which is called out in the next question. So first thing you have to do with these questions, especially ones that have the uniform, is we need to figure out where exactly this is happening. Where is that line? And this is where you're going to use this bullet point here. The area under the curve must be 1. So if all of this is 1, then this must also be at 1, because we've got a rectangle, right? So this is 1 times 1, which is just 1. And then we can do these next pieces. The probability that we're between 0 and 0.8. This is the area that we're looking for. And we could just find the area of this rectangle. It's going to be 0.8 times 1, because that's the base times the height. Right, we could do the next one. This one says instead, let's go between 0.2 and 0.5. I give you guys a second to try that. Pause this. But same idea. Now you're going to figure out how you'll have to do a little bit of math to figure out that the base of that rectangle is 0.03. Right, because that's that difference. And then exactly equal to a value. That's exactly what we were talking about before. Being exactly at 0.5, that is 0. And I love questions about that, as you'll probably see on the next knowledge check, and also on the Kahoot that we might have. So just know that. I was going to pause this and make a new video, but the next one is quick, and I just want to get this over with. So our last exercise here uniform distribution. This is probably more similar to what you might see on a test. I would suggest pausing, trying this on your own, and then checking. But again, this one is a uniform distribution, so everything is equally likely, and the values can be anywhere between 0 and 5. And again, time to complete a question is continuous, right? So we could start by drawing out our cute little curve. Anywhere from 0 to 5 minutes to complete this curve. It's all equally likely. And then oops, I don't want to go past 5, so I'm going to redraw that. After 5 minutes, it drops to 0. Before 0 minutes, it's 0. So if you wanted to be really, really accurate, you could do that. And we are looking for the probability, right? What is the probability someone takes between 1 and 2.2? So let's just label this 1 and 2.2. Pretend my drawing is good. So we're looking for this area, right? If you wanted to use some, I guess doesn't matter if you have the inequality, if you have the equals or not, you could use this for your notation. What's the probability that our random variable x is between 1 and 2.2? Two ways you could solve this. One, you could think of this as a proportion of the curve, since everything is equally likely. So this is distance of 1.2 out of our 5 total things down there. The other is that we could do what we did in the last problem, and we know the whole area has to be 1, right? So then we can figure out what this value is. Since the area has to equal 1, and area is just base, which it looks like is 5, times our height that we don't know, we can solve and figure out that our height is equal to 1/5 or 0.2. So if this question mark is 0.2, then the area of the whole curve is 1, and we have a legitimate probability density function. And then finding the area of this rectangle is super straightforward, because we already know the base, which is 1.2. We just figured out the height by the fact that the area had to be 1 for the whole rectangle. And then we can figure out that probability, which must be 24%. So that's the correct answer. You'll see this in the knowledge check and also in the Kahoot. I do questions like this, mostly just testing this idea that probability is area under the curve. And the most intense thing I do is sometimes I'll throw a triangle at the back end, or I'll just give you a triangle to begin with, right? And so this is just, do you know how to find the area of a triangle or a trapezoid? So again, not terrible. Area for a triangle is half base times height. Area for a rectangle is base times height. Knowing just those two should be enough to get you any question I put on a test.